All right, so let's learn some new postulates that'll make proving triangles congruent a lot easier, because instead of having to show 6 sides are congruent and instead of having to show 3 pairs of angles are congruent and 3 pairs of sides are congruent, so all 6 things are congruent, we now narrow that down to 3. So we're going to do over two postulates today, the side angle side congruence postulate and side 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 congruence postulate. So let's actually write this down first, and then we'll look at what it looks like with the diagrams. Okay, so this side angle side congruence theorem tells you exactly what you need. You need 2 sides and an angle. What's special about this is it has to be 2 sides and their included angle of one triangle, and 2 sides and the included angle of another triangle. They must be congruent. So you want to make sure you write that down. And let's take a look at what I mean by included angles. Let's go ahead and call this triangle ABC. And then the second triangle XYZ. All right, so you need to be given, again, 3 things to show that to conclude the triangles are congruent. So again, 2 sides and the included angle. So for example, if we say we are given AB is congruent to XY, that's one part, right? All right, so that is one pair of sides. We could also be given that BC is congruent to YZ. So those are my 2 sides, the S and the S. But notice how the A is sandwiched between it. So when we talk about the included angle, and we talk about this included angle right here, we're talking about the angle that's right between the 2 sides. So the angle that's basically formed by the 2 sides in your SAS postulate. So again, what we need to see is that this included angle Y is congruent to the included angle here for ABC, which should be angle B. So if we were given that angle B is also congruent to angle Y, then we can conclude that triangle ABC is congruent to triangle XYZ by the SAS congruent postulate. All right, I put congruence here because next trimester we're going to talk about similarity, so I like to differentiate between congruence and similarity using that symbol. So that's why I put that there. All right, but again, the key thing with the SAS postulate is knowing the included angle. So think about why we can't say the triangles are congruent if we were given, for example, angle A and angle X instead of angle B and angle Y. All right. Next up, we have our side-side-side congruence postulate. So this one, hopefully pretty simple. You have the 3 things you need, all 3 sides. So let's go ahead and again write this down first, and then we'll look at the diagram. Okay, so hopefully this is pretty straightforward. It's in the name, right? Side, side, side. Basically, 3 sides of one triangle have to be congruent to 3 sides of another triangle. There's no getting around that. If we have those 3 things, then our triangles are congruent. So once again, you're looking for 3 things. Let's call this triangle ABC again. And let's call this one XYZ. And again, you need to show that 3 sides are congruent. So I could tell you, well, AB is congruent to XY. That's 1. Okay. Then you'd also need to know, for example, BC is congruent to YZ. That's 2. Oops, let me put that segment line on top here. And then the third thing we need to know once again is that final side for SSS. Okay, so AC is congruent to XC. If we have these 3 things, then we can say triangle XYZ congruent to triangle ABC by SSS congruence. Okay, so those are the 2 we're going to focus on today. Really look at what you have to be given. So again, it's 3 things, but you want to look very carefully. Are we given the included angle? Are we given all 3 sides? Before you can say yes or no. All right, let's take a look at example 1. And this is a good example with 3 diagrams showing us, well, are these triangles congruent or not? And really challenging you to see what you know. Okay, so let's take a look at A. What do we think? Can I use SSS or SAS? I think in A, very clearly, SSS is not going to work because I don't have enough information for all three sides. But what's interesting here is I know something about this line segment in the middle. Does anyone remember what this property is called when they share it? Hopefully you caught that. This is the reflexive property, right? So they're congruent by the reflexive property, which means I've got side, angle, side, right? Side, angle, side. So yes, by SAS congruence, because we've got this reflexive property. So I'm starting this right here. You need to make sure for this type of problem, you include that in your justification. So this is the tricky part. Look for those reflexive sides, right? Take a look at B. What do we think? Can I use SSS or SAS here? Well, hopefully you're seeing I've got no information about angle bisectors or congruent angles, so SAS is automatically out. But you also see this once again, we share this side here, which means we've got the reflexive property once again. So that's congruent by the reflexive property. And once again, remember, you need to have this in your justification, in your explanation. So since it's congruent by the reflexive property, I've got congruent sides here, congruent sides here, and a third congruent side. So yes, by SSS congruence. Okay, take a look at C. Remember, think about what you need to know. Find my duck, my neighbor just came home. So again, think about what you need to know for SSS and SAS and if it'll work. So if I look here, I've got a pair of congruent sides. I've got a pair of congruent angles, right? No information about the other, these sides out here, so probably not going to be SSS. Since I have an angle, I really want to try for SAS. So once again, let's look for that reflective side right here. So I've got this reflective middle side, but look at this carefully. Does it follow SAS for both of the triangles? Hopefully you're seeing it doesn't, because for this angle to be included on the left triangle, we need this to be the other side, right? Since we don't have any information about this side, we can't say the triangles are congruent. So again, that side needs to be congruent for it to be included, because this angle A right here that I labeled A right here, it's not touching this S at the bottom. So this one was a tricky one. This is no, because the congruent angle of the left triangle is not the included angle. Right? So that one's a bit tricky. If you have questions on that, definitely ask in class. Okay, example 2. Let's use SAS to explain why these triangles are congruent. So this is kind of like what we just did before. So I'm telling you SAS will work here. I want you to tell me why. So once again, think about what would make SAS work here. So I've got a pair of congruent sides and a pair of congruent angles. So the last side should be the side that creates the included angle, right? The last leg of that angle. So what do we see? What do you notice? Well, what should be that second side? Should it be AC and CD or BC? Well, hopefully you guys said BC. And what do I know about this BC? Hopefully, once again, you notice BC is reflexive to itself, so it should be congruent. So we can say BC is congruent to BC by the reflexive property. And then since AB is congruent to DB, and angle ABC is congruent to angle DBC, from our given, triangles are congruent by SAS. Congruence. Once again, for this one, you had to look very carefully what's going to make the included angle. So that's something you can't just randomly pick, right? You want to look at where the angle should be and what the side should be based on that angle, okay? So let's take a look at example 3. How would I show these triangles are congruent? Now using some algebra, using some numbers. So remember, look at the diagram first and see, well, what am I trying to use here? Am I trying to use SAS or SSS here? Well, I'd want to use side, angle, side, because notice I'm given angle information, right? So since we have angles, oops, it was really sloppy. So since angles are given in the diagram, let's try SAS congruence. All right, so that's what I'm thinking about in my head. So let's go ahead and plug in things to see if it will work out. So if SAS would work out, we should show that AD is congruent to CD, right? DB is congruent to DB because the angle is right in the middle of AD and DB, right? And then angle ADB is congruent to angle CDB. So that's my checklist. I want to show that the triangles are congruent. So plug it in, right? AD is equal to 3t plus 1, which will be 3 times 4 plus 1, which is 13. DC is equal to 4 times t minus 3, which should be 16 minus 3, which is 13. Awesome, right? Since AD is equal to DC, AD is congruent to DC. Check. All right. DB is congruent to itself by the reflexive property. Check. Finally, the angle, so the measure of angle ADB is given to me as 32 degrees. The measure of angle CDB is equal to 2 times t squared, which is 2 times 4 squared, 2 times 16, which is definitely 32 degrees. So since the angles are equal, they must be congruent by your definition of congruent angles. Check. So since these all work, triangle ADB is congruent to triangle CDB by SAS congruence. So this is important. You need to tell me that final statement. And again, what's important is you have to show me these 3 things in your work, right? Let me kind of highlight that. So right here, we've got this from your definition of congruent. We've got this by your reflexive property. So again, tell me that property here because there's no work really to prove that. And here, my third statement, 1, 2, 3, SAS. Okay, finally, a proof. So again, this chapter, a lot of it's going to be on proofs because we're proving triangles congruent. That's the big idea for this chapter. It's about triangle congruence. So what I like to do is I like to list out my possibilities for proving the triangle is congruent. So we have our definition of congruent triangles, which I'd rather not use because there's so much going on with it. We've also got SAS congruence and we've also got SSS congruence. I'll take the information in the diagram to help me determine which one we're using here, right? So look at your givens and look at the diagram to help you out with it. So if you look at the given's giving me something about an angle. So if I'm talking about an angle, I'm immediately going to think probably not SSS. I'm going to try to not use this definition of congruent triangles if I can. So my goal is to use SAS. And I'll do this in a flowchart to show you how the logic works. But if I want SAS to work, that means these are the 3 pieces of information I need to show, right? You can always go back to the names of the triangles to help you figure out the congruent parts. But we need to show that 2 sides and an included angle are congruent. I'm going to look at the given. Since we're given information on angle RQS, I'm probably going to try showing that, well, the 2 parts of RQS are congruent. So angle RQP needs to be congruent to angle SQP. Now, if that's the angle I'm trying to show here, right? If this is what I'm trying to show, what are the 2 sides to go with it? Well, in the triangle RQP, it's got to be side RQ. Oops, let me fix that for you. So side RQ. What does that correspond to? Well, that's going to correspond to side SQ. Okay. Then what's the other side that would create the included angle RQP and SQP? Well, it's got to be QP and QP. And hopefully when you're seeing QP and QP, you're immediately thinking about one certain property. All right, but here's my checklist. This is what I want to do to make SAS work because this is the angle that was given to me. So again, just using some logic to work through it. Let's go ahead and now build your proof. So QR is congruent to QS. That's handy. That's given to me. And that's right here. Check. Okay. And then remember, if you see something congruent to itself, what is that reason that we're going to be using more often than you think here? That's right. That should be the reflexive property of congruence. Check. Finally, I need to get this pair of congruent angles. So look at your last given. QP bisects angle RQS. Oops, RQS, right? That's my given. Remember, what does bisect mean? Use that definition of that vocabulary word to help you take it one step further. Remember, bisect means to cut in half. So that means, by definition, those two halves are congruent. So angle RQP should be congruent to angle SQP by your definition of angle bisector. Right? And check. Now, once I have these three things, 1, 2, 3, I can say the triangles are congruent by my targeted reason, SAS. And that's it. All right, but again, the tricky thing about this, even though we reduced our checklist down from 6 to 3, you need to look for the right sides, the right angles. And that could be the tricky thing. So definitely familiarize yourself with the diagrams, really think through what it should look like. All right, and we'll keep practicing this in class. See you guys later.